Hi everyone, welcome back to Math with Vanch. I'm Vanch and I'll be teaching you math, obviously. Now in the last video we looked at product rule and quotient rule, and both of these rules are super important in terms of taking the derivative of any given function, and it really kind of expands the ability of what functions we can take the derivative of. Now in this video is going to be super short. It's just going to be looking at some of the other trig functions. Now we've already looked at the sine function and the cosine function in terms of derivatives. So in this video, we're going to look at the tangent, cotangent, secant, and cosecant functions. So if you're ready, I am too. Let's get started. Okay, so I'm just going to write out the derivatives of these functions really quick. So 6 basic trig functions, right? We got sine, cosine, tangent, cotangent, cosecant, and secant, right? So I'm going to write all these out, and I think you're going to see a pattern. So we already looked at the derivatives of sine and cosine in one of our previous videos, where we also looked at the derivatives of e to the x and natural log of x. So from that video, we remember that the derivative of sine of x is just cosine x. And similarly, the derivative of cosine x is just going to be negative sine of x, right? Now, we still have 4 functions to take care of, and those are tangent, cotangent, secant, and cosecant, right? So how do we take the derivative of those? Now, there's no way to really prove this, so I'm just going to write them down and you got to memorize them. That's really the easiest way to do this, and they're really not that hard to memorize, and there is a pattern that you're going to see to emerge. So for tangent, the derivative of tangent is going to be secant squared x, or secant x squared. So these are obviously just 2 different ways of writing the same thing. Now, the derivative of cotangent is also very similar, but instead of secant, it's cosecant, and there's a negative. So cotangent x is just going to be negative cosecant squared x, or in other words, negative cosecant x squared. Now, just remember the negative is outside of the cosecant, because if it was inside, then the negative would just cancel out. You would just be left with cosecant squared, right? So negative cosecant squared x is the derivative of cotangent. Now let's get into secant. Now, as we remember, secant is just 1 over cosine, right? So for secant and cosecant, we can actually prove this using the quotient rule, which I will do in 1 second. So secant x, the derivative of this is just going to be secant x times tangent x. And it's kind of weird to see one of its own functions in the derivative itself. But it's also the same way with e to the x, right? Because the derivative of e to the x is just e to the x. And with secant x, it's just secant x times tangent x. And then same thing for cosecant. If you're starting to see the pattern, you might be able to guess that it's going to be negative cosecant x cotangent x. Now, there's kind of a pattern here, and as you can see, all the trig functions that start with a c, like cosine, cotangent, and cosecant, they all have a negative in front of them. So that's a really good way to memorize it, is that all the trig functions with a c are going to be negative. Well, at least the derivative of them are going to be negative. Similarly, all the c functions seem to go together, right? Like, except for cosine x, but these two are kind of different. But like with cotangent x, the c matches with the c, so cotangent, cosecant. Similarly with cosecant, the c's match with the c's, so cosecant and then cosecant cotangent. So if you look at the c's in the trig functions, then you can actually kind of start to narrow it down a lot, because you already know that it's going to be negative, and then the c's go with the c's. So for cotangent, it's going to be cosecant squared, and for cosecant, it's going to be cosecant cotangent. So these are just all the trig functions real quick, just laid out to memorize. And I would say memorizing them would just be the easiest way to do it. There isn't really any other way of figuring these out, except we can do quotient rule for all of them, right? Which is what I'm going to do right now. Okay, so we're going to start off with tangent x right now. And as we recall from our trig practice, tangent x is equal to sine x over cosine x. So now for this, we can just use quotient rule if we substitute this in for tangent x, right? So if we wanted to take the derivative of tangent x, so we can substitute this and make it sine x over cosine x. And now we can do quotient rule. So we can do low d high minus high d low all over the square of what's below, right? So we got our low function, or the denominator, which is cosine x, times the derivative of the top function. So the derivative of sine of x is just going to be cosine x. So cosine x again. And then minus the top function, which is just sine of x, times the derivative of the bottom function, which is the derivative of cosine x, which is negative sine of x. And then all over the square of the denominator. So all over cosine squared x. Okay? Now if we simplify this a bit, we get cosine squared x. The negatives, the double negative becomes a plus, and then sine squared x. And then all over cosine squared x. Now, this is actually one of our Pythagorean identities, right? Cosine squared x plus sine squared x. We know that's just 1. So this actually simplifies further to 1 over cosine squared x. And this is just secant squared x. Right there. So this is how we prove that the derivative of tangent x equals secant squared x. Now, we can do this for every other function too, but I'm not going to, because I'm going to be honest, the easiest way to kind of know the derivatives of all these trig functions is to just straight up memorize sine and cosine, right? And then for all of them, I'd also recommend just memorizing them, because in the long run, having to do quotient rule for every single trig function that you come across is going to become super tedious. So I'd say just memorize all of the separate trig functions, and you'll see that it's actually not too hard once you start to do it. However, if you do randomly forget one trig function, you should know you can always do quotient rule and kind of get there the hard way. But overall, I just say memorize them, and it'll make your life a lot easier. So yeah. So that is going to be all for today. The video does end Unit 2 of AP Calculus, which pretty much just dealt with derivatives the whole time. And in Unit 3, we're going to start looking at more advanced derivatives and also like more rules that we'll find. So yeah, I hope you found this video helpful, and please let me know if you have any feedback in the comments. Otherwise, I will see you for the next one. Bye-bye.